This lecture discusses binary search tree or BST in short. Binary search tree or BST is a binary tree with a special property where for every node all elements in the left subtree are smaller and all the elements in the right subtree are greater than the element in the subtree's root. So, these are the three important properties of binary search tree. All items in the left subtree are less than root. All items in the right subtree are greater than or equal to the root. Each subtree is itself a binary search tree. A binary search tree is a special type of binary tree. We have already seen what a binary tree is. In this lecture, three operations on binary search tree are discussed: searching, insertion or creation, and deletion. Both creation and deletion makes use of search operation. So, search will be discussed during insert operation. The following example illustrates a binary search tree insertion procedure. So, this shows an example. We have a binary search tree here. You can see that all the nodes which are of the right to the root are greater than or equal to the root. So, if you take 23, you can see that 44, 35 and 52 are greater than the root. So, if you take this subtree, you can see that the right subtree is greater than, right element is greater than or equal to the root, and left element is less than or equal to the root. So, likewise here also, left one are less than and right one are greater than or equal to. So, if you consider the case of inserting an element 19, so we will be starting from root, then we will be checking element by element. Since we are trying to insert 19 and the root is 23, which means that you need to insert at the left subtree, since 19 is less than 23. So, we will be go here, then we will be checking with 18. So, our element is 19. So, we need to go to the right, here it is 20. So, we need to go to the left and we will be placing 19 on the left. So, likewise, if you are trying to insert 38 after that, we will be going to the right, 44 greater than, so 38. So, left, then right, and we will be placing 38 here. So, you can see that both of these insertion happens at the leaf. So, in a binary search tree, the insertion happens at the leaf. Or also I can say that binary search trees are inefficient when the tree is unbalanced. So, if you have some elements which are always less than, say we have 3 or 4 elements, 23, then 18, then 12, in this order, then I insert a 5, then if I insert a 2, you can see that this tree is left skewed. So, if you have a tree like this, there won't be any advantage in searching or maybe traversal operations. So, binary search trees are inefficient when the tree is unbalanced. So, this is a particular case which won't be occurring more often.